Okay, Tom. Tom Wirsing is our demonstrator, and I'm going to give him a little bit of a bio, but he can give us much more one. He's going to do a gallery review. Tom was ex-military and an all-around nice guy. Lives kind of somewhere around Hygiene, Niwot, Longmont area. He has been involved in turning for quite a while, been very involved with the AEW for a long time. In fact, if you get your monthly AEW magazine, he seems to be the featured hat model every month. And Tom is both a former board member and president of the AEW, so he's been contributing for quite some time. He's very well known for what he's covering today, which is how to make really nice, really flat, really nicely finished platters.
Okay, great. This is where we're going. This is a platter that has not been touched by any sandpaper, and you can see it's pretty smooth. I turn a lot of figured maple. It's often quite rippled with figure. If you sand rippled figure very much, it will ripple the surface of the wood. So you got to get it smooth off of the tool. And I'm going to talk about how I turn and how I smooth my wood to get it really smooth before I touch it with any sandpaper. I'm going to use negative rake scrapers after I turn the wood. So I'm going to remove 99% of the wood with my gouges, but before I touch it with any sandpaper, I'm going to smooth it with negative rake scrapers. And I will use a series of negative rake scrapers to do that. I'll show you quite a bit of detail about that as I go. A lot of people think that any wood turner that scrapes a lot is a bad wood turner. I think any wood turner who sands too much is a bad wood turner, and that anything I can do with my tools to avoid sanding is good technique. And I'm going to talk quite a bit about that tonight. I'm going to pass this around. Again, it has not been touched by any sandpaper. Okay? That's everything you see there is straight off of the tool. So let's talk about the anatomy of a well-turned platter. I'm not going to ask you to like my style of platter. I like things that are very simple. I want the quality of my wood turning, the beauty of the wood, and the finish to do all the talking. Okay? So I don't like a lot of doodads. I don't like to decorate things. I like real simple things that are well turned out of nice wood and well finished. So that's kind of where I'm going to go. So again, I'm not going to ask you to like what I've turned, but I will tell you that there are certain characteristics of a well-turned platter that we all ought to know about. So first of all, when you run your hand across a platter, you shouldn't feel anything, okay? There should not be any ripples, any dips, any mounds, anything, any tear out, anything that you feel. Your hand ought to go across it. It ought to be absolutely smooth. The rim should be slightly sloped inward. If it's not, it'll make the whole platter look kind of slump-shouldered. So the rim should be sloped in, and it should be slightly crowned. So if you put a straight edge across that, it's going to rock a little bit. Why? The reflection of the light off of that rim will be more pleasing to the eye. I like sharp transitions, crisp transitions at every point on my platter. So if you look at the transition between the rim and the interior, there's a crisp line of demarcation around it. Same thing on the edge. I want the top of the rim and the bottom of the rim to have a nice crisp line around it, okay? A lot of people want to round that off. And if it's rounded off, I don't think it looks as nice. I think it's more difficult to get it crisp, but it also sets your wood turning apart. Turn it over. I want a nice smooth ogee curve from the foot to the rim. I want the rim to be slightly undercut where your fingers go into it when you pick it up so that it feels good in your hand. Again, I want a nice crisp line around the outside and the inside of the foot. I want the area inside of the foot to be slightly crowned so that it kind of mimics the curve on the inside. I do not like this curve to be undercut where you enter the center. I think that is kind of tacky looking, frankly. A lot of woodturners think it looks nice. I think it's kind of tacky. So again, I like simple, clean wood turnings, nice wood, well finished, and I'll talk a little bit about that as I go. I will tell you I'm not going to do any sanding tonight. So I'm going to turn wood, but I'm not going to do any sanding. I am very careful when I do sand. When I'm sanding some rippled wood, I will put sandpaper on a neoprene pad, adhesive back sandpaper on a neoprene pad to keep from rippling the wood as I sand. So, but again, I'm not going to sand tonight. I never power sand anything. If I'm going to go to the trouble to get it as smooth as that piece that's going around, I'm not going to touch it with a power sander. I would destroy all of my hard work if I power sanded it. So one of the nice things about negative rake scraping before you sand is it doesn't leave you much work to do when you start sanding because it's pretty smooth already. So you know, there's some advantages, some big advantages to using the negative rake scrapers. Okay, so yes.
So you deal with fairly dry wood?
Yes, Chris. By the way, I'm going to try to repeat questions, and if I don't repeat it, ask me to repeat it. If you don't understand my answer, make me explain it better. And by all means, if the answer doesn't make sense, stop me and make me explain better, okay? So I'm turning dry wood, and the technique that I'm going to use tonight is only for dry wood, particularly with regard to the way I'm going to chuck it. And if you look at the handout that has the process steps, you will see that there's an underlined area there saying this is for dry wood only. Do not do what I'm going to do with wet wood. First of all, a negative rake scraper will not work on dry wood. Secondly, if you tried to chuck it up, wet wood, sorry. If you tried to chuck it up the way I'm going to chuck it, it would come out of your chuck, and then you'd be in trouble. Well, there's some beautiful pieces just coming into the instant gallery there. I wish they had been there a little earlier. Okay, so I'm gonna revert to my PowerPoint just quickly. Get through this in a minute. I'm going to use two-step turning process. By two-step turning process, I mean to shape the piece. 99% of the wood is removed with my gouges, but before I do any sanding, I negative rake scrape every square millimeter of everything there. Edge, rim, everything. Okay, so anatomy of a well-turned platter. I've covered most of this already, so I won't cover it again, but you can sort of see where I'm going with this. I should tell you I'm left-handed. So if you see me do something that looks a little backward to you, it could be because I am left-handed. I turn pretty much ambidextrously, but I am left-handed. So the best of us are. You see that I've brought two grinders. I'm going to use my grinders a lot. A sharp tool will cut highly figured wood beautifully. A dull tool will tear everything. So I am a stickler for keeping my tools really sharp, and you'll see me grind a lot. I'll go through that in more detail as I grind. I'm not going to sand anything. And as I said, I never power sand anything. If you can't see what I'm doing, if the camera is not getting what you need, let us know, please. We may not know that you can't see exactly what I'm doing. And again, I want the camera to come in tight on my work when I'm working, because I'm mostly going to talk about technique. And the techniques that I'm going to talk about, I'm turning a platter tonight, But if you're turning a bowl, the same techniques are equally applicable to a bowl. I turn a bowl exactly the same way I turn a platter. So it happens to be a platter tonight, could be a bowl tomorrow night, okay? Questions? I will try to repeat the questions. If you don't hear the question or don't understand it, let's stop me and let's get it straightened out. Yes?
I guess I have a question. Why are you against power sanding, or could you explain that a bit?
Yeah, sure. If you look at the piece, okay, the question is, why do I not power sand? If you look at that piece that's coming around that has not been sanded at all, it is so smooth already that, number one, if I did power sand it, it would be less smooth after I power sanded it than it was before I power sanded. And in the process of power sanding and power sanding up to finer and finer grits, I would destroy a lot of the accuracy of the turning that I've produced. A negative rake scraper, the cutting edge of a negative rake scraper, if you look at it under a microscope, looks for all the world like sandpaper. And it acts like sandpaper, but it is much, much more accurate. You can get that piece perfect with a negative rake scraper. Sanding never improves anything. It might get it smoother, but it sure won't get it better. That is a lot better than anything that's power sanded could ever be. Look at it. Tell me if you think you could power sand that and get it as well turned as that is. Okay? Fair enough? Okay. So let's move on. Okay, these are the two gouges that I'm going to use, and neither of those is a 40-40 grind. The one on the left has a V flute and swept back wings, and almost all of the cutting that I do with that tool is on the left wing. The one on the right has a U flute, is ground at 65 degrees. So the left one is ground at 40 degrees. The right one is ground at 55 degrees. I'm turning figured wood. If the nose of the gouge is too sharp, it will get up under the fibers and ruck them up. So I shouldn't have said too sharp, too narrow an angle on the cutting edge. So the 40 degree gouge will rip wood away quickly, remove wood quickly. The gouge on the right, ground at 55 degrees with a U flute, has a long straight nose, and it will slice the wood fibers away. And if I keep it really sharp, it cuts like a dream, and it does not get up under the wood fibers and ruck them up. So it's a real good gouge to use on figured wood. There's another look at the two gouges. You can see in this picture the differences in the flute. The one on the left, V flute, the one on the right, U flute. And the one on the right, the nose of that tool has a long straight edge, which is very helpful in cutting wood. So here's how the left flute cuts. The left cutting edge cuts. It is cutting into side grain, and it's peeling the wood away. And I'll explain that more as I get into it. Whereas the finishing gouge is slicing the wood at a very acute angle at the cutting edge. And again, it's ground at 55 degrees, so it doesn't get up under the wood fibers and ruck them up. Okay? This is just a look at some of my negative rake scrapers. I have a number of different shapes, and those shapes all have their purpose. Those are quite precisely ground. They may not look like it in the picture, but every one of those is ground quite precisely. I do have one scraper, which is not a negative rake scraper. I use that scraper to cut the recess to mount the piece when I'm turning the upper side of it. I'll explain that when I get into it. And then here are just a couple of quick pictures of some of my wood turnings. This one is very similar to the one that I just talked about. This piece is decorated with ostrich shell. I don't normally decorate my work, but that's an exception. This piece also has an India ink drawing on it. I don't normally draw on things either, but that's an exception. Okay, and there's a bowl. And again, the bowl is using exactly the same techniques that I will use to turn the platter tonight. Okay, let's make a little sawdust. You will note that this piece is mounted on a faceplate. And a lot of people think that mounting anything on a faceplate is overkill. But if your piece vibrates at all while it's being turned, you can't get it really smooth. So I start every piece on a faceplate, and it takes a little extra time to do it, but it's really worth it because the end result is much, much better. Okay. Boy, this thing is stiff as a... Woo. Question was, what kind of screws do I use to mount? These are McFeely's square drive screws. They are hardened steel screws, square drive. They have a narrow shaft and deep threads. I drive them with a impact driver, but I never drive them all the way down with the impact driver. I always go that last half turn with a hand driver, because you can break any screw, but these are the toughest screws. I've got screws that I've used for 5 years, over and over and over again, and they're still just as good as they were when they were new. Okay, so rule of thumb is that you want the foot to be approximately a third of the size of the diameter of the platter. So the first thing I'm going to do is measure this, and this is about 370 millimeter. And by the way, I'm going to talk metric. It is much simpler to use metric measurements than inches and fractions of inches. The English did a lot of good things, but their measurement system wasn't one of them. At any rate, I want the foot on this to be approximately a third of this, so a little more than 120 millimeter. So I'm going to spin this up. Look at, wow, there we go. And where's my face screen? And forgive me, but I'm going to wear a face screen. Can everybody hear me okay? All right, good. Turning a big piece of wood without a face screen is a fool's errand. Okay, so, and I'm just going to find the center. And rather than make a dot in the center, I'm going to make a little round bright spot in the center. And then I'm just going to measure out, what did I say, 120 millimeter? So I'm going to measure out 60 millimeter in each direction and draw a circle. And that's about where I want the outer diameter of the foot to be. But this is a demo, so I'm going to make the foot a little bigger, because I don't want this thing coming off of my chuck. If it comes off my chuck, the only thing you guys will remember is that it came out of the chuck. So I'm going to use a Vicmark chuck with dovetail jaws, and I have a little cheater stick here that's exactly the length of my jaws when they're tightly closed. So I'm going to use that to tell me where to cut the recess. And I'm going to use that to chuck the workpiece to turn the upper side of it. And by the way, the faceplate is always on the upper side. So I look at my piece of wood, decide where the nice grain is, and I'll put the faceplate on the side of the workpiece that I think looks the best. Okay? Okay. The question is, how deeply do I want the screws to go into the workpiece? And that's a good question. Typically about 1/2 to 3/4 of an inch. And as I said, these are good strong screws with nice deep threads, so I can get away with and I usually in my shop I'll use 4 screws. This is a demo. Again, I don't want this thing coming out in the demo, so I'm using 6 screws, and they're probably going in about, these are 1 1/4 inch screws. The faceplate takes up some of that length, so I'm thinking these are probably going in 3/4 of an inch. The workpiece is about 2 inches thick, about 50 millimeters thick. So I'm going in, approximately 1/3 of the thickness of the workpiece. Okay.
Would you use longer screws if you had a thicker piece?
No. The question was, would I use longer screws with a thicker piece? No, I would not. I would use shorter screws on a thinner piece, but not longer. But I'm serious. So the first thing I'm going to do is cut the outside of this round. By the way, will somebody be my timekeeper and tell me when I've got 30 minutes left? What time do you want me to finish? 8:30. 8:30. Okay, so 30 minutes. No, at 30 minutes. I don't care what time it is. 30 minutes, 15 minutes, 10 minutes, 5 minutes, 2 minutes. Okay? Make sure you let me know. I don't want to run late. Okay, so the first thing I'm going to do is use a gouge, and I'm going to use my V gouge just to cut this edge round. And so my grain orientation is this way. Okay, so if I use the tool on its cutting edge along its left cutting edge and just peel into the wood, it'll cut nicely. So you're going to see me peel this thing to shape it, to rough shape it, by using the left wing of the tool and just going straight into the wood this way. So the first thing I'm going to do is use that technique to cut it round. And I don't want to go off the inner edge, so I'm just going to turn around and scrape that off so I don't shatter the edge. Next thing I'm going to do is just face the upper face just a little bit so that I know how much wood I've actually got there. I need to know that before I start turning it, because I certainly don't want to get it too thin. And again, I'm just going to use the same gouge, and I know you can't see this, but I'm just going to skim it on the inside to get this. Get it down so that I am flat, and it's down all the way out, so that's good enough. Then I'm going to do the same thing on this side. And this, I'm just going to true it up enough that it runs true, doesn't vibrate much. Okay. Okay. Then I'm going to cut the foot, the recess for the chuck to go into. I'm going to cut that right now before I go any further. Tool rest is a little bit low. Not supposed to move my tool rest when the machine is running. And I'm not going to go in very deep. About 3 millimeters is enough, about 1/8 of an inch. If this recess is sized properly, it doesn't need to be very deep. So I'm going to take a little more out of it. That's not quite deep enough. Okay. And then I'm going to use that one scraper that I showed you that is not a negative rake scraper. I'm going to use that to cut the recess. And the nose of this scraper is ground at an angle that matches the angle on my dovetail jaws. I want this recess to be just large enough for the fully closed chuck to just barely go into it, so that when I open it into the recess, the chuck jaws are in a perfect circle, and the recess by definition is in a perfect circle, and I can get away with a very shallow recess. It'll hold this securely, and it's not dangerous. Okay, so I'm just going to use this to cut in. Okay, that's plenty deep enough. I'm going to use one of my finishing gouges just to clean up the area inside the foot, because this is the most secure chucking I'm going to have of this piece. Once I've turned it, I don't have the advantage of having it on a faceplate anymore. So I'm going to clean this up a little bit right now. And as I said, I'm going to scrape every square millimeter of this piece before I'm done. So I might as well scrape a little bit of this right now and just get it cleaned up. And when I'm scraping, you can see I'm not putting any pressure on the nose of the tool at all. If you have to push the tool into the wood, the tool is dulled and it'll do more harm than good. So look at my right hand. No pressure at all. Okay. Yes. Question?
2 questions.
Yes.
Hello? Okay. First of all, I noticed you came across center with the scraper. I assume you're touching it softly enough that's not an issue. Is that correct?
The question was, how do I get away with starting my scraper over center? And one of the things I do with these scrapers all the time is to make sure that I don't have either a rise or a dimple in the middle. And you can do that by starting the scraper over center. I am very careful not to let anything on the right side of center dig in, but I use that technique all the time.
The second question I have is your tool rest. Does it require a nice smooth tool rest to bring a nice clean cut across the surface?
The question was, do I really need to keep my tool rest cleaned up well so that the tool can slide across it easily? I'm pretty anal about all of my equipment. So, I do keep my tool rest cleaned up. And if it gets nicks in it, I'll clean it up with a file. And I'm pretty careful about how I do that too. I hold the file along the entire edge so that I don't get a saddle in it. So don't create a saddle. I mean, my lathe is 21 years old now, and it's as good as it was the day I got it. So, okay. Yes? I shouldn't show it to you because it it doesn't have any particular shape. This particular scraper, this corner of this scraper is what I use to scrape the inside and the outside of the foot. And just this little bit of it right up on the corner. The nose of it is just straight. And it turns out that to cut this area, any scraper with a straight nose would have worked just fine. I just happened to pick this one up. Almost every scraper I have has at least some part of the edge which is straight. And that helps me to pick up the cut without creating any ripple. So I know these scrapers don't look like they're precisely ground. They actually are very precisely ground. Each one is ground to do a very specific job, and I'll show you that as we go through the demo. Okay? So before I go any further, I want to make sure that my chuck will go in my recess. And as I mentioned, I want that recess to be just barely big enough for the chuck to go into it, so that when it's barely open, and you can see that that the kerf in those jaws just has a slight crack now. The jaws, the outer edge of those jaws is almost in a perfect circle when the kerf is a couple of millimeters wide. So I've got this recess cut absolutely precisely. That will hold well, even though the recess is shallow and it's a big piece of wood. I have no fear that this will cause me any problems. Okay, so let's do some bulk removal of wood and get this platter to begin to take shape. And I'm going to sharpen my tool. Don't try to follow me here. I'll drive you crazy if you do. These are CPM 10V tools, and I'm sharpening with CBN wheels. This particular wheel is 350 grit, so it'll get this tool quite sharp. You can see that I'm grinding very gently. Don't need to grind hard. Okay, let's begin to shape the underside of this platter. So I mentioned that I'm just going to peel and I want a little bit of undercut just at the edge. I mentioned that. Makes it feel good when you pick it up. And then I'm going to begin to step up. So I'm beginning to shape the underside right now. And again, I'm just peeling into the side grain. I need to stop talking and start paying attention here. Can anybody explain to me why this thing is doing what it's doing? No, I should straighten up the cutting edge so that where it touches the wood is absolutely vertical when it first touches, and then open the flute and push in. And I'm not getting it. I'm not doing what I should do. So that's the rough shape of the underside. This is not producing a good cut. Again, I'm cutting with the cutting edge almost horizontal to the direction of travel of the wood. That is not going to produce a pretty cut. And I'm not rubbing the bevel. I'm actually angling the tool in so that it's ripping the wood out more quickly. And now, this is really rude. But you can see that I've got it to a shape that I want pretty quickly. My foot is not quite as tall as I'd like it to be, so I'm going to take a little more wood out there. Okay, and then I'm going to switch to my finishing gouge, and I'm just going to try to clean up that entire surface. And I want this gouge to be really sharp. This is a 600 grit wheel, and again, this is a U-flute, so it has a lot of It has a long cutting edge that is fairly straight, much straighter than the V-flute would have been. And you can see I'm just barely touching it to the grinder just to clean up the cutting edge. I've got wood chips inside my glasses. I can't see what I'm doing here. Yes. Yeah, I'm being sloppy. Why is the tool running? Okay, let me explain it. More clearly. When the tool enters the wood, you want the cutting edge, as it enters the wood, to be vertical. I'm cutting on center. If I'm on center, I want the cutting edge to be vertical so that it doesn't want to skate in either direction. But as soon as I get it in and I've got some wood that the bevel is rubbing against to stabilize the tool, then I can open the flute up. At that point, the cutting edge is no longer vertical and it wants to go in that direction. Okay? It wants to skate toward the center. So what I was doing is I was not getting the cutting edge absolutely vertical when I entered the wood because I was too anxious to open it up and get it to cut quickly. I know I don't have as much time tonight as I would have in my shop, so I'm trying to go a little too fast. That's what is causing it to run. And, you know, when I've got plenty of wood there, I don't mind if it runs a little bit. But when I start getting up close to my foot, if I let it run across the bottom of the foot, that's deadly. That'll ruin what I've done. So I'm a little sloppy. I can get away with it. But when I start getting close to the foot, then I got to be more careful. So I'm just trying to go too fast. Yes, sir. This is the 40. Yes. This tool is ground at 40 degrees. Again, it has a V flute. So almost all of the, I'm sorry? I'm not going to cut. I'm not going to cut. So the cutting edge is ground at 40 degrees, and because it's got a V flute, I've got a lot of wing on it, and that wing is what I'm using to cut. And again, it is just peeling into the side grain. So you saw how quickly I removed all of that wood with no trouble at all, except for my skating a little bit. But you'll forgive me for that, I think. I hope. So, again, now I'm going to take my U-flute and I'm going to try to keep the cutting edge of this pretty much. If this gets in the way of the camera, let me know. But this is producing a bit of a shadow. Okay, so I'm gonna use the this tool, and I'm just going to skim down the surface. And try to clean up some of the carnage that I've left behind with my other gouge. Now, excuse me, I mentioned that I want a little bit of undercut here, so I'm actually going to come out to the edge and come back in. And I want you to notice also that this is running out some, okay? This is a piece of pretty dry wood. Why is it running out? Exactly. What I've done is removed a lot of stresses from the wood that I've cut away, and the end result is that it's running out already. So you may think that this wood is not well seasoned. The fact of the matter is, it wouldn't matter. It would be misbehaving to some degree anyway, and I've got to be pretty careful cutting this. Okay, so again, I'm gonna come into the low point from both sides. Okay, so let's just stop this and have a quick look and see how it looks. Okay, I don't have as much tear out as I would have thought I would have had at this point. So this piece of wood is gonna be fairly easy to turn. So What I'm going to do now is scrape it. So I'm going to start with this scraper to turn the edge of the foot. I'm going to get rid of this little discontinuity I have, and it'll produce a nice smooth curve, and I'll be able to use this tool down to about here. And then this curve is concave, so I'm going to switch from this one to this one using the flat nose of that tool to pick up the cut and then go down into the recess, okay? So I'll start with this one.
Question, Tom?
Yes, sir.
So you have the shape you want for the bottom now. You're just smoothing. Is that correct?
Yeah, I've got it. I've got the shape pretty much the way I want it.
Okay.
So again, I've removed 99% of the wood with my gouges, and all I'm going to do now is use the scraper to smooth it. Okay? Okay, so negative rake scraper. The scraper is ground the same on both sides, so it's ground at the same angle, top and bottom, and that angle is 22.5 degrees. So it gives me an included angle at the tip of the tool of 45 degrees. These tools are CPM 10V tools, so they've got a lot of vanadium in them. They've got a lot of vanadium carbides in them. The matrix, the metal matrix, is about Rockwell 60 or 61, but the vanadium carbides are way up in the 70s in Rockwell hardness. Makes the tool very abrasion resistant, and as I said, it's a particle metal tool, so I have billions of very small, well-distributed vanadium carbides along the cutting edge of this tool, and these are really good tools. But you've got to sharpen them on a CBN wheel. A conventional wheel will not get them sharp. So I can get away with this tool because the steel is quite hard. I can get away with a 45-degree angle on the nose of the negative rake scraper, and it'll hold its edge pretty well. So if you tried this with an M2 tool, you'd want to probably use a grinding angle of about 35 degrees so that the nose of the tool was 70 degrees. This is 45 degrees, okay? Make sense? All right, I'm going to sharpen it up. This platform is set at 22.5 degrees. The wheel is a 180 grit CBN wheel, okay? Again, very gentle grinding. You don't need to grind hard. And I can see that this platform is not exactly where it was. It probably got dinged in the car when I brought it up. So I'm going to have to grind a little more than I ordinarily would like to get a burr. I can see that I still don't have a burr. Okay, I can see it coming up now. Okay. And I'm going to feel for the burr. If I don't have a burr, the tool will not cut well. If I have to push it into the wood at all, it's dull. And I do not want to push it into the wood. I want it to cut smoothly without being pushed. So, you hear that little oscillation? That's my enemy. If this tool is oscillating, it's not cutting smoothly. And if you don't think that this is cutting well, look at the chips I'm getting. Okay? Most people think a scraper is going to produce sawdust. This tells you that this scraper does a lot more than produce sawdust. It cuts. Okay? And look at my right hand. I'm not pushing the tool into the wood at all. If you have to push it, it's dull. Okay, that's about as far as I can go with that because I'm beginning to get into a concave surface here, so I need to switch to the other tool. But again, I'm using the flat nose to pick up the straight nose to pick up the tool. And again, look at the chips. This is cutting quite well. And I'm probably going to have the same problem with this tool that I had with the other one because my platform seems to have moved a little bit. So I might have to grind a little more than yep. Same thing. I'm not getting the burr yet. Okay, just a little bit more. Sorry about this. Okay, so I'm going to finish this by using the nose of this tool to pick up my cut without creating any discontinuity, and I'm going to just bring it down to the bottom, and I'm going to get it down in that recess and smooth it up. And I'm not pushing the tool, it's just kind of gliding across the surface. And look at the chips I'm getting again. So it's cutting very nicely. Okay, so I want to stop this and see what I've got, because if I've got any tear out, I want to fix it right now. I would much rather fix tear out with a scraper than with sandpaper. So I've got just a teeny bit of tear out up here. I am gonna hit that one more time, just quickly, and I'm going to sharpen the scraper again. I know I just sharpened it, but I'd much rather spend the time sharpening my scraper and getting rid of the tear out than having to sand the tear out. So. And I've got, my fingers are much better than my eyes at this point in picking up things that aren't quite right. It feels really good. But this is where I had the tear out, right in here. So I'm just going to go back and forth a little bit with the scraper and see if I can get rid of that. Okay, that looks pretty good. Let's stop it and look. I think I had a little bit of discontinuity somewhere. No, that's actually some figure in the wood. It's not, that looks okay. All right, that'll do. Now, if I were doing this in my shop, I would be sanding this right now before moving on. But I'm going to stop and scrape my foot. I actually adjusted this platform when we got here tonight, but obviously there's a very slight difference in how it is sitting and how it was sitting when I ground these tools last time. It got dinged a little bit in the car. So sorry about having to grind my scrapers more than normal. So now I want you to look at the handle when I'm cutting this. I'm not going to hold the handle parallel to the bed. I'm going to actually push it over toward you a little bit. Why am I doing that? Can anybody tell me why I want the cutting edge to be slightly angled? Not tapered. I want it to be exactly. I want the underside of that foot to be a section of a very shallow cone, so that when it hits the table out the outer periphery, not at the inner periphery. That will make it sit more stably on the table. And I don't want it flat, because if there's any irregularity on the table, a grain of salt or something that's not quite flat on the table, if it's conical, slightly conical, it's much more likely to sit nicely on the table. So I'm just going to clean this up. And you can see that my handle is angled in just very slightly. Okay? Now, before I go any further, I want to take this off and just look at everything and make sure that I'm happy with it.
How much of your purchase surface did you lose?
Huh?
For your big mark truck when you just did that? You got a couple of millimeters. Did you just lose a millimeter there?
Yeah, less than a millimeter. Probably a half millimeter. There was, the surface of the wood was not entirely smooth. Came out of a sawmill, not entirely smooth, and all I was doing there was just smoothing that up. So I probably took a half a millimeter off. Okay, is everybody okay with the millimeters as against inches? A half a millimeter is about a 64th of an inch, maybe. Yeah. Okay. All right. So one thing I'm going to do before I go any further, you see this edge? If I get my hand up against it, that'll cut me like a knife. In fact, if you look at my hands, you can see right there, I was turning one in the puppy, and it drew blood. So I'm going to blunt this right now. I'm going to round the edge right now, round it over a little bit so that it's not sharp. Okay. Now, again, I'm not going to sand anything tonight. I don't want to sand in a demo. I got folks sneezing already. So I'm just going to sharpen up my scraper and hit that edge again, just to make sure that I've got it nice and smooth before I move on. I should have tinkered with that platform and made it match the tools instead of grinding my tools to match it. Now, I don't want this transition to be sharp, but I do want it to be crisp. So I do not want it rounded over. I want a nice distinct line there. Okay, I hope that's smooth. And this is a good time to stop and just look, because once I start cutting the top of the platter, start shaping the top of the platter, this rim is going to begin to run out, And again, it's because the stresses in the wood have been removed, and that will cause it to run out. Okay, that's good enough on this side. So I'm going to take it off of the faceplate. Okay, so I'm going to take it off the faceplate. Melinda, would you come get these screws and pass them around? A number of people have asked about them. Yes. Doug's comment was that David Ellsworth favored more screws with less engagement rather than fewer screws with greater engagement. And Doug's comment was, what's the thought on that? When I'm in my shop, I use 4 screws. This is a demo, so I'm using 6. But I've never had any difficulty with a piece coming off of the screws. So I'm also typically turning either platters or bowls where I've got a lot of wood. If you're turning something thin, then by all means, more screws with less engagement. But for platters and bowls, my feeling is I'd rather drive fewer screws and drive them a little deeper. And if the wood is solid, that has never caused me a problem. So I'd have to say, David does a lot more decorative work than I do. And I suppose he's probably turning maybe thinner work pieces than I am. Don't know that, but that would be my guess. And that's probably why he prefers more screws with less engagement. Does that make sense? Yes, sir.
Do you have any recommendations on parameters for the OG shape? Like, to what dimension is it concave versus convex?
I think that the question was, how do I size my OG? How do I go about figuring out how to shape it, how to size it? And I just go on what I think looks good. I grew up in a house in Virginia that had a lot of American period furniture in it. American period furniture tended to be simple and beautiful with flowing lines and very leggy sense, if you will. And I've always just kind of liked that feel. So that's why my wood turnings are simple and why I like nice flowing curves. The size of the OG is entirely by eye. In a sense, it is a little bit driven by geometry because the foot, you want the outer diameter to the foot on a fairly decorative piece to be about 1/3, and that does to some degree drive the contour of the OG. But I think that what looks good to you is just fine. And I would also say that what looks good to me may not look good to you, and vice versa. And I think you need to make it so that you are happy with it. Does that make sense? Mm-hmm. So I've taken this off of the faceplate. I am ready. Wow, that is a little tough to go. I am ready to turn the upper surface. But before I do, I'm going to drill a hole right in the middle of it to within about 12 or 13 millimeter of the underside. So right around a 1/2 inch. And I'll show you how I'm going to do that. I have a jig This is my drill press. This is my drill press. And I've got this jig set so that the drill bit goes to within, I'd say that's about probably 12 millimeter, maybe a bit more. And I'm going to use this and drill a hole right in the middle. The hole needs to be right in the middle. And if it is, you can see that hole when the wood is spinning, and it relieves the necessity to put any calipers on anything, because you can see how much wood you've got left as you're turning. So, so here we go. This is a very fancy drill press. Yeah, if you want to hold it to keep it from spinning. It's not likely to spin, but... Okay.
Tom, when you put your screws in, do you go across like you do with
The question is, do I put the screws in symmetrically? And the answer is yes. When I'm putting 4, they're at 90 degrees apart. When I'm putting 6, they are at what, 60 degrees apart. No. The question was, do I tighten in a crosswise pattern? And the answer to that is no. I put the first screw in, and I always use a punch on my face plate to get that first screw exactly where I want it. So I find the center, I draw a circle on the piece. You can see the circle. That circle is exactly the same size as the faceplate. I carefully place the faceplate on it, and for the first screw, I'll put a punch in and hit it with a mallet and make a dimple. That helps the screw go in exactly where you want it without pulling the faceplate off center. Okay? Then I'll go to the other side, punch it, and put a second screw in and tighten it down. And again, I don't drive the screws all the way down with my impact driver. I always drive them that last half turn with a hand driver with this guy, because you can break the screws. Even though these screws are tough as nails, you can break those screws pretty easily. So the question was, do I drill a clearance hole? I have seldom had wood that was hard enough that I needed to. I won't say I've never done it, but I will say I don't normally do it. I can't remember the last time I needed to. I want to get all of the swarf out of that before I put it on my chuck. And I don't have a brush with me. I've got quite a bit of swarf down in there. See if I can get that out. That looks fine. I hope that will run smoothly. Now, I'm going to put it on my chuck, and I mentioned that I had very carefully sized that hole so that when the chuck expands into the hole, it's almost in a perfect circle, and it appears to be just right on. If you noticed, I didn't tighten that thing very tight. Okay? If you over tighten anything when you're putting it on a chuck, you're asking it to be off center when you spin it up, because the wood is compressible, and if you crank down on a chuck in a situation like this, it's gonna drive it off true. Okay? So that recess is very precisely sized. You do not need to crank down on it, and it's pretty shallow. It's probably 2.5 millimeter deep, and that'll hold this thing quite well. Okay? Yes, sir. Okay, so all I want to do is drill a hole that's within about a half an inch, 12, 13 millimeter, of the underside of the platter. So all I did was set this thing so that when the bit is fully down, it's about a half inch, about 12 or 13 millimeter from the bottom. Okay? If I'm at home, I do this with a drill press. I just set the drill press and set the stop so that the tip of the drill bit is about 12 millimeter off of the table when I drill the hole. Obviously, I couldn't bring a drill press in here tonight, so this is my substitute drill press. Vinny, did that make sense? That's correct. Well, the recess for the foot is about 3 or 4 millimeter deep. So, yeah. So when I get done, if I set the thing at 13 millimeter or 12 millimeter, I'm going to have about 8 or 9 millimeter left of thickness right in the center of the interior of the platter. Does that make sense? Everybody follow that? That was a long explanation to a short answer, to a short question. Okay. So, next thing I'm going to do, yes? 33. Woo! Okay. I think I can finish in 33. I'll do my best. Okay, so the next thing I want to do is kind of figure out how wide I want the rim to be. So what I'm going to do is spin this thing up, not real fast, and just draw a circle on it. And then I'm going to stand back and I'm going to look at it. I think that's a little narrow. I'm going to give it maybe another millimeter or millimeter and a half. See how I think that looks better. Okay? That's how I figure out how the rim's going to be. And there's nothing magic about it. It's just what looks good to me. Now, I'm going to cut away enough wood that I can slope the rim in, but I am not going to cut the center out of this until I have cut the rim and gotten it completely finished. Because as soon as I take the wood out of the middle, this thing is going to wobble. Okay, and exactly what we've been talking about, as I remove stresses, it's going to run out. I know that. It's a piece of dry wood. It's going to run out. So I'm just going to take enough wood out right now. And again, I'm going to make darn sure that if this is going to run, it's going to run to the inside, not to the outside. So I was very careful to get the cutting edge vertical before I moved into the wood. And fortunately, it didn't run. It's good. So that's enough. I've taken enough wood out that I can shape my rim now. And how am I going to cut the rim? Exactly the same way I cut the other side. I'm going to peel it with the side of my tool. I'm going to use a slightly smaller tool on the face because I'm not going to be removing as much wood. Okay? How many of you think that's going to produce a good cut? It's not, because I'm holding the cutting edge almost perpendicular to the direction of travel of the wood, and I'm not rubbing the bevel. I'm just ripping the wood away. Gently, but I'm still ripping it away. So what I'm going to do now is switch to my finishing gouge, and I'm just going to clean that up. And again, you can see I'm grinding frequently, but very gently. And again, that's a 600 grit CBN wheel. So, and I'm just going to pick up the cut with the bevel rubbing. Open the flute just enough to, just enough to. Well, that wasn't very smooth. Let me see what's going on here. Yeah, I'm getting some tear out. Let's cut that again. And I'll cut it a little more gently. Again, the cutting edge is forming an acute angle with the direction of travel of the wood. Well, this is less than impressive. All right, that's a little better. Okay, let's take a look at that. Hopefully we got, I still got some tear out. Okay, I need to be sharper and more gentle. So let's do it one more time. How thick? How thick do I want the rim? Well, it's going to vary a little bit. The edge of it here is probably about 8 millimeter, but it's slightly undercut on the underside. So I'm guessing I'm down to about 6 millimeter right in here, and then it's going to get much thicker because the bottom it drops away. So it varies, but I would say the rim is probably, well, let's just measure it. Actually, that's 10 millimeter. Okay, so that's a little bit thicker than I thought it was. It's about 10 millimeter, so I'm probably down to about 7 where it's undercut, and then it's going to get much thicker down here. It's probably 15 millimeter down there, okay? And you can hear it. It's already. You can hear it. It's. Okay. So I've got 30 minutes. 25 minutes. Okay. So, I've cleaned up the rim with my finishing gouge. Now I'm going to scrape it. Okay. So, very gently. Whoa! And it does not like that. You can hear it screaming at me. So, and if it's oscillating, if it's making any noise at all, it is not cutting cleanly. So what I want to do is dampen that. So I'm going to plant my hand firmly on the tool rest, get a piece of paper towel behind it, and dampen that vibration. Oh. Oh, this piece of wood does not like this. Let me sharpen up. Okay, let's see how that looks. That felt better. Yeah. Okay, and it looks like we've got almost no tear out. So that's good. So let's take the middle out. Okay? No, it'll be gone before it's... Okay, so again, I'm just going to peel. My lighting is not very good here. Is that okay camera wise? Okay. All right. Okay, so I'm not at the bottom of my hole, so I've got some more wood to go. So I guess I'll step it down again. See if I can get a little deeper. Okay, there's the bottom of my hole, so I'm almost there. I'm going to switch to my big finishing gouge. I have two sizes of each of these gouges. So I'm going to switch to the big one, sharpen it up. And again, even though this is grounded at 55 degrees, if you keep it sharp, it'll cut like a dream. 20 minutes. Okay. Okay, I'm a little high right in the middle. That's what I want to be. I want to be slightly high, not low. If I'm low, I got to go all the way back to the rim to fix it. Okay, let's just see what we got. Got a little tear out right there, but not bad. I'm surprised. This piece is more cooperative than I thought it would be. Okay, so let's scrape. We're going to clean this up with the scraper. And again, this scraper might not look like much, but it is quite precisely ground. It is ground in such a way that the straight across the nose will let me pick up the cut, and I will go over center, making very sure that I do not allow this corner to dig in. But by using the straight nose of the tool, I will guarantee myself that I have neither a dimple nor a rise in the middle. And then the swept back cut on the left wing allows me to go all the way out to the rim with one tool. Okay? Yes, ma'am. Actually, that's a good question. I want that to be straight across there because I can use that to cut a very square shoulder if I want to. So that is useful. It's not useful right now, but it is useful for other things. So that also is a good question. That piece of steel. That piece of steel cost about $125. Okay, and I really, yeah, I really do not need another one. I mean, I understand why you're asking the question, but the fact of the matter is that having this square helps me. I know you doesn't look like it would, but it does, because if I watch this corner of the tool and keep it almost touching but not touching, it will guarantee me that I have a smooth curve with no undulations all the way out. So that square corner actually helps me. Okay? 15 minutes. All right. So I'm going to, I didn't sharpen it yet, did I? All right. So let me sharpen. Okay, and you'll see me after I grind feeling for the burr. The burr is always on the upper edge as it comes off of the grinder. And I need that burr to cut. If the burr is not there, it will not cut well. So, and I'm going to start over center. And I'm watching that sharp corner. And I want it as close to the wood as I can get it without actually touching. And one of the reasons why I like this light coming down from above is that it lets me see the nose of the scraper very clearly with no shadows. Okay, it's beginning to oscillate, so let's get some dampening behind it. And again, that oscillation is definitely not your friend. If it's oscillating, you cannot cut it cleanly. It will not cut cleanly. Look how much it's running out, by the way. You can see why I didn't want to remove the center until I had that rim. Now this area that I'm cutting in when I'm getting up close to the rim, if you've got any tear out in the area where you've got end grain, so every half revolution you've got side grain and end grain, okay? If you don't get the tear out where you've got end grain, you cannot sand it out. You will distort the thing if you try. So it's really important that you get it cut cleanly with the scraper, because you're not going to get it clean with sandpaper. I would, regardless. Now, if I'm doing a bowl where there's a lot more wood to remove, I would do it in more steps. But essentially, I would take it down in stair steps, if you will, using the side of the tool to peel into the side grain. Now, if it's an end grain piece, hand me that tulip bowl, the little walnut one. Okay. Some people don't believe I ever turn anything but platters, so there's proof that I can turn something else. At any rate, this is end grain. So with this, the technique for removing the wood in the middle is entirely different. But for a side grain piece, I would step it down, peeling into the wood with the left wing of the tool. It's the easiest way to do it. Did I answer the question? I'm still not sure I understood you completely. Okay, all right. 10 minutes. Okay, I got to stop talking and finish this. So I'm just going to start with the tool over center, and I'm keeping that sharp corner right down at the wood. And if I do that, it guarantees me that I'm not going to have any undulations, any discontinuities as I come out. Now it's beginning to oscillate, so I need to stop that, because I can't, if it's oscillating, it will not cut cleanly. So I'm going to put my hand on my heel of my hand on the tool rest to keep my hand from oscillating. I've got the the handle of the tool tucked up under my arm. My fingers are on the tool rest to help me guide the nose of the tool, and I'm trying to keep it from oscillating. Okay, that felt pretty good. So, at this point, my hands are a much better judge than are my eyes. I want to feel that I have no discontinuity on this. And I can feel that I have a very slight discontinuity about right there. Okay? So, I'm going to mark that where I can feel it rise a little bit more steeply than I want. Okay? And I'm just gonna go back through that with my scraper and clean that up. How much time?
7 minutes.
7 minutes. It's like an eternity. Okay, so very, very gently, I want to see if I can get rid of that I can feel it. It's probably 1/10 of a millimeter at the most of discontinuity, but it's just rising a little bit faster than I want it to. And again, I'm looking at the corner of the tool and making sure that the corner of the tool is down at the wood as I move to the left. And if I keep it that way, I will guarantee that the surface doesn't have a discontinuity. Okay. And that feels real good. Okay. I don't see any tear out that I would have trouble sanding out. Okay? Again, if I had tear out where there's end grain, it would be very difficult to sand it out. That looks pretty good. Okay, so I'm going to take it off of the chuck, and I'm going to show you how I would finish the foot, but I'm not actually going to do it. And the reason I'm not going to do it is that if I do, I can't rechuck this piece. Okay? If I take away that recess by which I chucked it, I can't rechuck it. So what did I do with my chuck wrench? Under the platter. No wonder I can't see it. There it is. Thank you. So I'm not going to actually do this because I don't want to remove that recess because it'll prevent me from sanding the piece and finishing it. But I'm going to show you how I would do it so that at least you've had a complete yeah, these are. I have a Vicmark VL300. The question was, what is my lathe at home? I have a Vicmark VL300, and it's a long bed lathe. They're no longer made, and it is a wonderful lathe. That lathe is 21 years old now, and I've never needed to do anything to it. It just keeps right on going. It's a really good machine. And I can tell you that the Powermatic 3520C, which is what this is also a really good lathe. This is a wonderful lathe. And when you consider the cost of it, it's a very It's a very good lathe, and it's a very cost-effective lathe. I don't like everything about it. I mean, I complained a minute ago about the placement of the spindle lock, but I can tell you it's a darn good lathe. So again, you can see that I didn't crank down on this very hard, using one hand and not going hard. So what I would do is take my gouge and just cut away the recess, okay? Just go in and cut it away. I would take my scraper that has the radius nose on it, and after I'd cut it with the gouge, I would smooth it with this, and I would work all the way out to the middle and remove any tear out that I had. And what I would end up with is a curve on the inside which mimics the curve on the outside. I would leave this slightly domed so that it kind of mimics the curve on the inside of the platter. There you have it. Oh, man. So I think the lady in the back was first, and then you're, I think, second. So you had a question? At what grit do I begin to sand? Yeah. So should I be truthful or should I? I would typically probably start at about 180. And you might think that I could get away with finer sandpaper, but the fact of the matter is that if you start too fine and then you get up to 400, you're going to see things that you missed, because little teeny irregularities that don't show up at 220 will sure show up when you start getting up to 400 or 500. So I've learned the hard way that instead of being a hero, I'll start with slightly coarser sandpaper, and usually I'll start at 180. That's usually coarse enough. The workpiece that I passed around is plenty smooth enough to start at 180. Probably smooth enough to start at 220, but you know, if I start at 220 and I get up to 500 and I find something, I got to go all the way back, not to 220, but to 180 to get rid of that and then bring it all back. So I've learned the hard way. Don't be a hero. Start at about 180. Occasionally, if I've got something that is really difficult, I'll even start a little coarser than that, maybe 150. I'll never go any coarser than that. But the majority, 180, 220, 320, 400, and then an Abralon pad, slightly dampened, very slightly dampened, at 500, rubbing radially, so I'm across the scratch pattern that's created by the other sandpaper, and then finish. And the finish that I use is a blend of equal parts of oil-based gloss, interior polyurethane, pure tongue oil, and odorless mineral spirits. Equal parts of the three makes a very good finish, and very forgiving finish, and a finish that can be redone anytime you want to clean up an old piece that's gotten kind of beat up. The finish is very forgiving, so it will allow you to rub it down with a fresh coat of finish anytime you want to. Exactly. It's the only finish I have used for years. So just mix up a batch or bribe me and I'll bring you some. And you can rub it down. And what I would do is rub it down with a 500 grit Avalon pad. I would put the finish on the pad and then rub it radially. Just scrub the entire thing. Back and front, scrub it down really well. Do not let the finish dry on it. As soon as you've rubbed it down, wipe it completely clean and set it aside. And if in a day or two it still looks like it needs a little more, do it again. Wipe it completely dry again. Do not let any of the finish dry on the surface. If you do, you will never forgive me. The question is really about negative rake scrapers and why a negative rake scraper works well. Basically, conventional wisdom says that a scraper should be honed on the top so that its cutting edge is really sharp, no burr, and it should be held nose down to keep it from catching. That's the way a conventional scraper is typically sharpened and used. A negative rake scraper is ground the same top and bottom so that the nose of the tool, the upper edge of the nose of the tool as it addresses the wood, is already sloped down. What that means is that the tool will not catch. Furthermore, it will not self-feed, and it is held horizontally on the tool rest, which makes it incredibly easy to control. And you saw that I was not hanging on to the butt end of that tool at all. I was just resting it in my hand. It is incredibly easy to use. So a conventional scraper is more difficult to use. It will self-feed, and it does not clean the surface up as well because it has a very sharp cutting edge, whereas a negative rake scraper, if you look at it under a microscope, and I have a little microscope that I use in some demos, if you magnify that to about 300 power and look at it under a microscope, the cutting edge with a good burr on it looks for all the world like sandpaper. That's why you see me feeling for that burr when I come off of the grinder, when I bring it off of the grinder. And the burr is always on the upper edge as it comes off of the grinder. You'll also notice that I ground those scrapers top and bottom. I can't explain why, but that seems to produce a slightly better burr, and the burr is what cuts. And you saw how that burr is cutting. It cuts in ribbons. It cuts beautifully. Negative rake a conventional scraper typically produces sawdust. Now, if you're a Richard Raffin and you're turning green wood or wet wood with a conventional scraper, you can make the thing do miracles. I mean, what he does with a conventional scraper is miraculous. But most of us are not Richard Raffin. It's okay. The first part is really important. You're adding mineral spirits to your finish to thin it. So the polyurethane must be oil-based, and it's becoming harder and harder to find polyurethane that has mineral spirits as the diluent. Okay, it's really hard to find it in Colorado. However, Home Depot, if you buy a quart can of Varathane interior gloss polyurethane, if you buy a gallon, it doesn't have mineral spirits in it. It has some other junk in it that smells awful. I don't know. Yeah, it has to be clear. It's clear and it's gloss. And the reason I say it's gloss, varnish that is matte or not gloss has some sort of ground stone in it usually, and it compromises the quality of the finish. So you can make it any reflectivity you want with whatever you rub it down with for the last coat. I usually use 500 grit Abralon. You can use 1,000 grit. In fact, I just repaired a bowl for somebody that had damaged it. It was 12 years old, and the finish was shiny. And I rubbed that down with 2,000 grit Abralon to maintain the reflectivity of the finish. But I usually rub the finish on with a 500 grit Abralon pad, and I'm rubbing radially, so I'm going across the scratch pattern when I apply the finish. And I'll put that piece has, I think, 4 coats on it. And the first coat, I flood it and keep it flooded for 20 minutes. and then wipe it completely dry and set it aside for a couple of days to flash off. And then I will, same Abralon pad, exactly the same finish. I'll scrub up another coat on, wipe it completely dry, and set it aside for a day, and I'll do that maybe 3 times, 4 times, until I get the reflectivity and the uniformity that I want. So it's a third oil-based gloss interior polyurethane. Do not use spar varnish. It's way too soft. You want a good hard interior polyurethane. And by the way, polyurethane is a urethane finish, and poly means that it'll polymerize. Okay, that's what poly means. The second ingredient is pure tung oil, and most tung oil is junk oil, frankly. If it says pure tung oil, then it's nothing but tung oil. If you buy tung oil in a can and it doesn't say pure, it's probably mostly linseed. Okay, the airplane with the tung oil flew over at 40,000 feet. Okay, and then and I use odorless mineral spirits. You don't have to use odorless, but it's much less smelly.
So, Tom?
It's worth the additional cost. Yes, sir.
One quick tip on the odorless mineral spirits. You need to mix it up. I learned the hard way that sometimes mineral spirits, odorless, somehow settles.
Oh.
So you need to mix it.
Did everybody hear that? You gotta shake the mineral spirits up before you use it.
The odorless type.
Odorless type, okay. Yeah. I always use an Abralon pad to apply it just because it smooths the surface a bit as you go. We're over time. I don't want to hold anybody, but I'm happy to stay here and answer questions for as long as you guys want to ask. So
Sir,
thank you all for coming.
Thank you so much, everyone. Really appreciate it.